Have a nice day, everyone. I am Alvin G. Viñegas, and today's video is all about problem number 49, wherein an arrangement of dots forms the perimeter of an equilateral triangle. There are 101 evenly spaced dots on each side, including the dots at the vertices. How many dots are there altogether? Step 1 is to understand the problem. And it shows here that if this is an equilateral triangle, an arrangement of dots form the perimeter of the triangle, shown in this figure, wherein the dots are placed in the perimeter of the equilateral triangle, meaning the distance of each segments are congruent as shown in the figure. Step 2 is to devise a plan. In order to solve the problem, we will make a table and look for a formula in finding the total number of dots in an equilateral triangle using a fewer number of dots in each side. Step 3 is to carry out the plan. If the total number of dots in each side is equal to 2, then the total number of dots in an equilateral triangle is equal to 3. If the total number of dots in each side of an equilateral triangle is equal to 3, then the total number of dots in an equilateral triangle is equal to 6. If the total number of dots in each side of an equilateral triangle is equal to 4, then the total number of dots in an equilateral triangle is equal to 9. If the total number of dots in each side of an equilateral triangle is equal to 5, then the total number of dots in an equilateral triangle is equal to 12. Therefore, using the formula 3 multiplied by n minus 1, we can easily solve the total number of dots in an equilateral triangle. Since 3 multiplied by n minus 1 is the formula for the nth term, using the formula, if there are 101 evenly spaced dots in each side of an equilateral triangle, including the vertices, there are 300 dots altogether in the equilateral triangle. Step 4 is to look back and reflect. Now, what if the polygon is a square or a regular pentagon, a regular hexagon, heptagon, octagon, nonagon, decagon, or n-gon? What would be the formula in finding the number of dots? Step 1 is to understand the problem. Since if the polygon is an equilateral triangle, the formula is 3 multiplied by n minus 1. What will be the formula for the square, the regular pentagon, regular hexagon, regular heptagon, or regular octagon? Step 2 is to make a plan. To easily solve the problem, let's draw a picture and look for a pattern, then make a list. Since if the polygon is an equilateral triangle, we can solve for the total number of dots using the formula 3n minus 1. Now, if the polygon is a square, we can use the formula 4n minus 1, wherein from this figure, it shows here that there are 8 dots in the square. Now, if the polygon is a regular pentagon, we can solve the total number of dots using the formula 5n minus 1. Now, if the polygon is a regular hexagon, we can use the formula 6n minus 1. Now, if the polygon is a regular heptagon, we can use the formula 7n minus 1. Now, if the polygon is a regular octagon, we can use the formula 8n minus 1. And if the polygon is a regular nonagon, we can use the formula 9n minus 1. Therefore, if the polygon is an equilateral triangle, the formula is 3n minus 1. If the polygon is a square, the formula is 4n minus 1. If the polygon is a regular pentagon, the formula is 5n minus 1. If the polygon is a regular hexagon, the formula is 6n minus 1. If the polygon is a regular heptagon, the formula is 7n minus 1. If the polygon is a regular octagon, the formula is 8n minus 1. If the polygon is a regular nonagon, the formula is 9n minus 1. If the polygon is a regular 100-sided polygon, the formula is 100n minus 1. Step 4 is to look back and reflect. What if there is a common side from triangle to square, another common side from square to a regular pentagon, then another common side from the regular pentagon to a regular hexagon, and doing the same pattern up to step 100? What will be the formula in finding the total number of dots? And it shows here an illustration from step 1 to step 6. Step 2 is to devise a plan. To solve the problem easily, let's look for a pattern for the first 5 steps. Make a list, use variables, and some formula. Step 3 is to carry out the plan. Now, step 1, the formula in finding the total number of dots is equal to 3n minus 1. In step 2, the formula in finding the total number of dots is equal to 5n minus 1 plus 1. Step 3, the formula in finding the total number of dots is equal to 8n minus 1 plus 2. And this is the plus 1 and another plus 1. In step 4, the formula in finding the total number of dots is equal to 12n minus 1 plus 3. And these are the plus 3. In step 5, the total number of dots can be solved using the formula 17n minus 1 plus 4. And these are the plus 4 dots. In step 6, the total number of dots can be solved using the formula 23n minus 1 plus 5. And these are the plus 5 dots. Using a table, in step 1, the formula in finding the total number of dots is equal to 3 multiplied by n minus 1. In step 2, the total number of dots can be solved using the formula 5n minus 1 plus 1. And the total number of dots added is equal to 2n minus 1 plus 1. In step 3, the total number of dots can be solved using the formula 8n minus 1 plus 2. And the total number of dots added is equal to 3n minus 1 plus 1. In step 4, the total number of dots can be solved using the formula 12n minus 1 plus 3. And the total number of dots added is equal to 4n minus 1 plus 1. In step 5, the total number of dots can be solved using the formula 17n minus 1 plus 4. And the total number of dots added is equal to 5n minus 1 plus 1. In step 6, the total number of dots can be solved using the formula 23n minus 1 plus 5. And the total number of dots added is equal to 6n minus 1 plus 1. Therefore, the total number of dots for the nth term can be solved using the formula x multiplied by n minus 1 plus y, wherein x is the summation of n minus 1. And these are 3, 2, 3, 4, 5, and 6. And it shows here that from the second term up to the last term, the total number of dots added, or the total number of n minus 1, is a series of sequence, wherein these are 2, 3, 4, 5, 6, and so on. Since 2, 3, 4, 5, 6 is a series of sequence, we can use the formula S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n, since that common difference is equal to 1. and y is the number of sides of the last polygon added minus the number of sides of a triangle. Now let's find the formula in the step 100. X is equal to 3 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 up to 100. Since from the second term up to the last term, it shows a series of sequence, we can use the formula S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n. Since the first term is eliminated, S sub 99 is equal to 99 over 2 multiplied by 2 plus 100. And S sub 99 is equal to 5049. Therefore, X is equal to 5049 plus 3, which is equal to 5052. In step 100, the last polygon added is a 102-sided polygon. Therefore, y is equal to 102 minus 3, which is equal to 99. And using the formula x multiplied by n minus 1 plus y, let's substitute the value of x and y. Therefore, the formula in step 100 is equal to 5052 n minus 1 plus 99. Therefore, in step 100, if the total number of dots in each side is 100 including the vertices, then 5052 n minus 1 plus 99 is equal to 5052 multiplied by 100 minus 1 plus 99. 5052 multiplied by 99 plus 59 is equal to 500,148 plus 99, which is equal to 500,247. Therefore, if the total number of dots in each side is 100 including the vertices, then the total number of dots in step 100 is equal to 500,247 dots. Now, if the total number of dots in each side is 200 including the vertices, then using the formula 5052 n minus 1 plus 99, the total number of dots is equal to 5052 multiplied by 200 minus 1 plus 99, which is equal to 5052 multiplied by 199 plus 99, which is equal to 1,05,348 plus 99, which is equal to 1,05,447 dots. And that's the end of my video presentation. Thank you for watching.